Hi, welcome to the Calculus 3 assignment practice series. And in this video, we're going to work on the assignment number 1 for the unit partial derivatives. And this assignment is about the functions of several variables here. And in fact, this is a pretty easy sections, so that we probably will not do too many of the problems in the worksheets here, all right? So let's go to the worksheets here. Okay, so here's the worksheet. The first problem I want to do here will be the problem number 14 here, okay? Let's take a look at the problem number 14 and see how do we do that. Okay, so let's take a look at the problem number 14. So like we talk about the domain is just the typical as we did in R2, right? So since this is even roots, that means whatever's inside here has to be what? So whatever is inside here has to be in the non-negatives, right? So that's why we said x minus 3y has to be greater than or equal to 0. So that means, so 3y, x is greater than or equal to 3y, or you can say the y is less than or equal to the 1/3 of the x here. So the domains for here, for the number 14 will be, so it will just be the xy, and y is less than or equal to the 1/3 of the x. So let's take a look at what is this domain looks like in the, the R2. So this is xy. Remember the R3 functions, the domain is in the R2, right? So it's x is less than or equal to 1/3. So I know this one's here, the x equal to the 1/3, right? So for the x equal to the 1/3, it will be the lines here, right? So this will be this line. So this line is y equal to the 1/3 of the x. So we said the domain has to be y is less than. So that means the domain will be everywhere is in these regions, right? So including the lines here. That's what we mean the graphic. Okay, so that's pretty simple. Then let's take a look at number 19 here. So for the number 19, this is y minus x squared. So the first thing here we said, if we have the denominator, so the denominator has to be what? Cannot be equal to 0, right? So we said that y minus x squared, is equal to 0. We need to exclude this number. So it's x squared equal to 1. So x equal to what? 1, or x equal to the -1 here, correct? Okay, then the next thing here is this square roots. So that means we know y minus x squared has to be what? Is greater than or equal to 0, right? So that means y has to be greater than x squared. Okay, so now let's take a look at what is this domain going to look like here. Okay, so the first things here, you see here, the y equal to the x squared, so it will be it's a quadratic form, right? So it's a quadratic form. And y is greater than x squared, that means will be everything inside. But also, it says here, right? So the x cannot be 1 or -1 because that is where make the denominator equal to zeros, right? So that's why we say, okay, so since cannot be, so we need to exclude that. So this will be 1, this will be -1. So that means this point cannot be there. And because this is in R2, right? So when x equal to 1, so that means all this point on the x equal to 1 line cannot be here. All right? So that's why the domains here will be what? The domains here will be everything inside And so will be everything inside here, but cannot be on these two dot lines here, right? So we'll be here, right? So we'll be here, 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 here. It can include these blue lines, and but now you need to see here, okay? Because this is the empty, because x cannot be equal to 1 and -1. So that's what is the domain going to looks like. Okay, let's take a look at the other ones here. The other ones here, this is in the R4. So I know my domain going to be in R3. And since this is a natural log function, so if it's a natural log function, what do we say here? That means, you know, everything inside the natural log has to be what? Greater than equal to 0, right? So this is 4x minus 4y minus z squared. This one has to be greater than 0, cannot be equal to 0, right? Okay, so now if you kind of move this one to the next other side, so you will have a 4x plus a 4y plus z is less than what? It's less than 16, right? Now you divide by 16, so this will give you x squared over what? Over 4 plus y squared over what? The one square, well, this is a 4, then plus z squared over 16 is less than 1. So we know this is the equation of the ellipsoid. So because it's less than 1, that means it's all the volumes inside. So let's take a look at what is this ellipsoid going to look like, right? So this is x, this is y, and this is z. Because z has 16, so let's has the longest axis here. So that's why we know this one, this ellipse are going to kind of standing up, right? So here, let's see here. So I hope I can draw it. So like this one, see here, then here it's going to have an ellipsoid, something like that. All right. So this is the, okay, so it's like, I hope that you can see that. That means they're going to touch here is 4 and 4. And now this is 2 and 2, right? And this is a 4 here, right? So that will be the ellipsoid. And I use the dot lines because this is less than 1. That means I cannot have the boundaries, right? So it will be everything inside this ellipsoid will be what will be the domains, right? So that will be the domain for these functions here. So the purpose for this problem, just want to tell you, if you have a function defined in R4, then the domain will be in R3. Like in here, those are the functions defined in R3, then your domain will be in R2. Okay, so the next things here I want to show is I want to do all the others here. You know, these ones here, you'll be able to use your software and try to graph it to see what it looks like. Okay, so let's take a look at number 33 here. Okay, so for number 33, so let's say this is a contour map. Oh, we call this like the you know, like we kind of call it a cross sections, right? So we call it a level curves here. So let's say, hey, use this to estimate this value after -3 and the 3's here, okay? So the f3 and the 3, so that means the x is equal to -3, so it's 1, 2, 3, and +3, 1, 2, 3. So it's this point, right? So this is the point. This is f of -3 and 3. As you can see, this point is between which two level lines here? This point is between these ones here, right? And this ones here. And this one is the level line for 60, level curve. This one is the level curve for what? For the 50. So they are right in the between. So I say the f of -3 to 3 probably is some value around 55. Of course, this is estimate. So now let's take a look at 3 and -2. So 3 is 1, 2, 3, right? 1, 2, 3. And -2 is 1, 2. So it's somewhere here, right? So this point is somewhere here. So just like you see here, you also go to see, hey, this point is between which two? So it's between this one and this one, right? So this point is between these two level curves here. So you estimate. So I will say this is 3, -2, right? And then this one's probably will be equal to what? Will be equal to around 35 here. And now let's say, what do you think about the shape of the graphs? So when you see the cross section, it's kind of like, it's not a total ellipse, but kind of like an ellipse. So probably it's some type of the cone, like in here, right? So in the space here, right? So then when you cross section that, so it's kind of like give you like the kind of ellipse shapes here, right? So that's what is we call this the contour map, or we call this the level curve here, right? Okay. So then the next one's here. So we said, hey, draw a contour map for the for the functions here. So I will take a look at the number 45 here, right? So for the several level curves here. So for this one, it's a little bit special here. So we said level curve is k is equal to the x squared minus y squares, right? Okay, so if you do, so here in general, this is hyperbolic, right? But then if k equal to 0, what do you have here? You have x squared minus y squared equal to 0. So what means here? So x squared equal to y squares, right? Then you take the square roots of both sides, so you will have y equal to what? Y is equal to plus or minus. So here, okay, so y equal to the plus or minus x here, right? So that's why you see here. So that means what are those things? Those are the lines here, right? Y equal to, so this line. So if they just equal to the k, the x squared minus y squared, when the k is not equal to zeros, right? And then we said x squared minus y squared equal to some number. So what is here? So this is the family of the what? Hyperbolic, right? Okay, so now if you want to draw the contour map here, so let's draw the contour map here. So see what it looks like. So here, this will be, okay, so here, okay, so here, let's see. Okay, so here. So the first we know when k equal to 0, I have y equal to, remember, y equal to plus minus x. So I'm going to have 2 lines here, right? Okay, then for the k is not equal to 0, depends k is a positive or negative, because it is the hyperbolic, so I'm going to have a curve like this, right? So, and here and here. Or if it is negative here, so then they're going to symmetry to the y, okay? And then you can verify this by using the software. And that's it. So I think this is sections of the assignments is pretty straightforward. And you can use the software to help you to identify what is the graphs looks like and what is the, we call it a cross section or contour map. It looks like to give you ideas. So, all right, that's it. And this is a pretty easy assignment, and hopefully, and I hope you can get a good understanding of the problems we did here, right? Okay, so nice to talk to you, and have a good day. I will talk to you in the next assignments here. Okay, bye.